All right, so let's hop ahead to number 6 because we covered this in class. Let's hop ahead to number 6 and make sure we all understand what's going on. This is day 5 worksheet for vectors. I'm going to cover number 6 in detail. We'll talk about 7 and 8 briefly. I'm going to hit pause and fast forward to a couple of problems on day 6. All right, so component form is just the difference of our x values for our a and the difference of our y values for our b. And remember, you have a starting point and an ending point, and R, because it comes before S in the alphabet, is our starting point, and S is our ending point. So I plotted R, I plotted S, connect them with a line. That is what we're looking for. We're looking for that direction and that magnitude. Okay, but first let's find the component form. Let's find the difference in our x values and the difference in our y values. We know it's going to go into negative world because we're going from R left to S, right? So component was x2 minus x1, comma, y2 minus y1. Okay, so negative 4 minus 1 is going to give me negative 5. And negative 6 minus negative 5 is going to give me negative 11. So I know my component form is negative 5, negative 11. Or I'm moving to the left 5 units and down 11 units from my original point to my new point. Okay, so my magnitude is just squaring those, adding them together, and then doing the square root of the whole thing to find the distance from R to S. It's the distance formula, right? So I do the square root of negative 5 squared plus negative 11 squared. Negative 5 squared is 25. Negative 11 squared is 121. Add them together and I get, what is that, 146. That's not a perfect square, but if we do that in our calculator, the square root of 146 is approximately equal to 12.08, right? And we're not using negative values because we don't go negative distances and all that stuff, right? Round to the nearest tenth, though. So in the instructions, it says round to the nearest tenth. So we're going to do 12.1. So we know that this distance from here to here is 12.1, or our magnitude is equal to 12.1. Now we have to find direction. So direction is not based on this original coordinate plane. We're going to make a new coordinate plane, and we're going to put this as our origin, the starting point as our origin. Okay, so really we're looking from 0 degrees all the way to where this line is. All right. We know a couple of things. We know that our A value, how far we move to the left, we know that our A value is negative 5. And we know that our B value is negative 11. So if you imagine this as one giant right triangle, right, we know that this side is negative 5 and this side is negative 11. So we need to find this degree measure, and we're going to add it to the 180 degrees that occurs here, adding that to find the completed direction. Okay? So how do we find that? We know that we have adjacent and we know we have opposite, so we're going to do tangent. So tangent of theta is going to be equal to, what is it, TOA, right? So opposite over adjacent. So opposite is going to be negative 11. Adjacent is negative 5. So in order to find theta, I actually need to do the inverse tangent on both sides. So theta is going to equal the inverse tangent of negative 11 over negative 5, or I could simplify that to say 11 over 5. The inverse tangent of 11 over 5 is inverse tangent 11 divided by 5 is going to be, let's see here. That is not what we're looking for. Inner tangent, opposite over adjacent. Or adjacent. All right, I was freaking out a little bit. I typed it in correctly. I know I'm doing the right math, and I got 1.144. And I imagine you know exactly what I did wrong. This is a school calculator, meaning my mode needs to be changed. So check your mode as well. Hit mode, go over to degrees, and then we're going to type it back in. So the inverse tangent of 11 divided by 5 is 65.55, right? So this degree right here is 65.55 or 65.6 degrees. And let's make sure that it doesn't say is around to the nearest tenth. Yeah, we're rounding to the nearest tenth. So we have 180 degrees to get from here to here, and then we have another 65.6 degrees to get to here. So our direction is actually going to be, what is that, 180 plus 65.6, which gives us 245.6 degrees. Okay. For 7 and 8, just remember that component form is translation. It is a form of translation. So our A represents our left and right movements. If A is negative, we're moving left. If A is positive, we're moving right. If B is negative, we're moving down. If B is positive, we're moving up. And remember, if our triangle, and that goes with all points, right? So triangle ABC is our pre-image, is what we start off with. Whenever we're talking about the new image, the new item, we would call it triangle A prime, B prime, C prime. Each point is prime, right? So, or if we were labeling points, we'd say A prime would give us such and such point, B prime would give us such and such point, on and on and on. Okay. So make sure you're saying that the new value is A prime, B prime. If we moved it from A prime to another one again, we would call that next one A prime prime. If we moved it again, we'd call it A prime prime prime, right? I'm going to hit pause real quick and move on to day 6, and we will continue. All right, kind of running through day 6 homework. It shouldn't take you too terribly long. 23 through 26 is just writing things in component form. Remember, it's x2 minus x1 for our A, and y2 minus y1 for our B. Remember, it's alpha order or follow the arrow. I think both of these follow both. So look at which direction the arrow is going. If there is no arrow, it's always alpha order. All right, 33 through 34 is finding the magnitude and direction. What you can assume for all of these is that each of the vectors start at the origin and use component form. So like for number 30, component is 2, 9. So use that to find your new vector, right? Or your vector total on the graph. Always start at the origin for 30, 32, and 34. All right. 36 through 40, you're just doing some simple math. It gives you the component form for vectors A, B, and C. Just follow the orders. Add A to C, subtract C from A, and then multiply B times 2 first, then add C. Remember, whenever we're doing addition between vectors, you're just adding let's do 36 through 40. Whenever you're adding, so like 36 says vector C plus vector A, you're taking vector C, A and B, and vectors A and B, and then you're adding these two together. So you're adding these two together to find a new one, and adding these two together to find a new one. And that resultant vector will be a new vector, or a new component form. Okay? Do that for both of those. On number 40, make sure you multiply A and B on vector B before you add it to vector C. Number 41, Amy hiked due east. This is 41. Amy hiked due east. Remember, due can be substituted with the word directly east for 2 miles, then hike due south for 3 miles. So if we have a north, south, east, west, she hiked due east for 1-2 miles, then hiked due south for 1-3 miles, right? So she went from here she went 1-2 miles, down 1-3 miles. So this was her vector. Okay. Use that. Let's see, how far is direction starting point. So describe it a different way. I know the key gives you what it's using. Try describing it a different way. South of, east of, north of, all that stuff. Try using some of our new terms. 42. Draw another picture, right? So 42 says a runner's velocity is 6 miles per hour due east. Remember, we can change the word with directly. So we draw a new graph. Due east is going to be this direction, due east. And we're going 1, 2, 3, 4, 5, 6 miles that way. And the wind blowing 2 miles per hour due north. 1, 2, due north. So we have these two things going on, these two actions going on, which allows us to have this new action. Okay. 43 and 44 are just a little bit more complex versions of adding and subtracting and multiplying vectors. A little bit more complex than 36, 38, and 40. Give those a shot. Let's see here. 54. 54 is two separate vectors. 54 is two separate vectors. Right? And it's asking you to find the magnitude of the resultant. So you can actually take the component form of this one, and it says find the sum or adds the vectors together, right? So we're adding these two new component forms. Draw yourself a new thing. Use the sum total component form to find your new vector, and that will help you find your new magnitude of the combination. Number 55, models an airplane that takes off. So an airplane takes off at 30 degrees elevation. So now we're talking about this right here, 30 degrees of elevation. How high will the plane be after traveling 100 feet horizontally? So we're going 100 feet this direction. How high will it be this direction? So this is what we're looking for. You can still use tangent because we have this degree measure, and we're looking for the opposite. So we have adjacent, okay? And if you recall, it's tangent of theta is equal to opposite over adjacent. We know theta is going to be 30. We know adjacent is going to be 100. We just need to find that opposite value. All right. 56 and 57, pretty straightforward. Draw a picture for number 56. Due north for 3 miles. Current flowing due east for 2 miles. It's going to help you out. And then which of the following is true about triangle RST? Run it through a few examples. A lot of them are talking about right triangles. Try to see if it works out. Do 10 squared plus 8 squared and see if it equals 13 squared. Who knows? Okay, try all those different things out. I hope that helps you out with today's lesson, and I will see you, not really see you, but I'll talk to you tomorrow. You'll see me tomorrow.